is make sure that everybody has all their dots. So let's try this again. Music, they call it DCL capo. Take it again from the top. We are recycling our paper here, so here's one of our dirty pieces. So again, we're drawing glucose. Alpha glucose. 6-membered ring. One of the ring members is an oxygen. So here's an O. We know there's 2 bonds. So now we just need to draw our triangles, right? Triangle to a triangle to a triangle. 1, 2, 3, 4, triangle. And now what we noticed was the one that's coming off is on the carbon next to the oxygen, so there's a triangle. So what we learn is that sugar's got a lot of waters hanging out on the end. I call OH kind of like waters because it's mostly all there is to it. So again, this being the alpha means that this O goes down. This O is down on glucose. Remember, we're doing alpha glucose. So alpha glucose has another oxygen. All these carbons, see they got oxygens on them? This diamond structure really makes it easy to see when they're on top or when they're on the bottom. This one up here, it doesn't matter, so we'll just throw that out on the side. So this oxygen probably belongs to that carbon because, see, every carbon's going to have an oxygen on it. So this one is considered that one because when it was flat, it formed up on a ring. So now that we have all the oxygens on there, these are OHs, alcohol groups, so we draw the dot in the middle. So that takes care of the 2 bonds on the oxygen. Oop, that doesn't get it. That does. I'm telling you, kids, this doesn't get any simpler. There's a proton on each of these, so boing, 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 boing. 2 on that because it's hanging out there. So the proton's on the carbon, and then you get the proton on the oxygen. So they number these too. 1, 2, 3, 4, 5, 6. That's why they'll call this 5' sometimes. This is the glucose molecule. And look how simple that was to draw. So now let's see when we get to a fatty acid. See if it gets much more complicated. And you know it's really not, because what we're going to find is once we're past what's called the triglyceride stage up here, there aren't going to be any oxygens. So it's just going to be diamonds. So let's take a typical what's called fatty acid. What makes it an acid are the carboxylates. So we got 1. That's why it's called tri. Tri is 3. And we know that the diamonds are always bound by 1 anyway. And what each of these gets, they all had OHs on them. Okay? So when we're binding these now, it's the O that holds them into place. So there's an O, there's an O, there's an O. And what makes the carboxylic acid is a carbon with a double bonded O, single bonded O. So since this was a carboxylic acid that went into that, for you dot freaks, let's get this going. 2 dots on the end, 2 dots on the end, 4 bonds here, so it only gets 1 dot in the middle. This is going to get an O here with 2. 2, go this way, 2. So now we just carry on the diamonds. Bond there to a diamond. Bond here to a diamond. Bond here to a diamond. And now, for those of you that like doing the dots, this is just going to be, a typical FAT is going to say there will be usually even numbers. So coming off this here is where we start counting. From the O's down, we'll start counting in twos. They're called betas. So 2, 4, 6, 8, 10, 12, 14 is a typical one. So we've got 1, 2, 3. See, now we'll take the lines out. We'll just draw a triangle on triangle. So we've got from the oxygens here, 1, 2, 3, 4, 5, 6, am I going to make it? 7, 8, 9, 10, 11, 12. These things can go on for a while. There's all different configurations and numbers of carbons in here. There's actually 2 essential fats. So vegetarians, you need to be really careful not eating meat because there's 2 fats that you need, oleic and linoleic acid, I guess. I get 2 of them mixed up. That's when you start hearing your omegas. That's where your double bond isn't in there. So see, these things get really easy to do because when you're going down, all these carbons are saturated, so they're just dot, 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 dot. Be like an old Morse code thing, dot, 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 dash. What's Morse code for fatty acid? Dash, dot, 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 dash. So, see how simple that is? This has to be more fun than drawing. And then the last one here is going to be a methyl. It's going to get 3 of them on there. So just picture how many carbons are running down the road here in your fatty acids. That's how they draw it. This is how we draw it. Make it more fun. And the way it really looks in 3D space, see, here's one they're showing. See the kink in there? That's one for like olive oil. So your straight saturated fats have no double bonds. Unsaturated have double bonds that'll add kinks to it. So I don't know if this book goes into as much detail as I like about the essential fatty acids. Oleic. So this is what's considered one of the essential fats. Oleic. And there are even numbers of carbons on there. How many are there here? They didn't draw it the way it should be. So we'll conclude there. Those are your diamonds. Diamonds for fats. Diamond circles for sugars. Am I saying diamonds, circles, triangles for your protein amino acids? So let's give a quick look at our balloons here. Balloon molecules. This is where we were yesterday. If we wanted to make a protein, we're going to need nitrogen. This is a sulfur. Boy, that'd be a compound, huh? NS. The little reds are the protons. This is why this is so neat, because the protons actually pop off in water and leave an ion. So what were we going to do? We'll take a nitrogen to a carbon. And see, we actually needed a carbon in between there, didn't we? How could we do that? We need another balloon. We got carbon with the oxygen. We would have a carbon in the middle holding the nitrogen to give it the amino acid structure there. Okay, my time's up. I gotta roll, folks. We didn't turn that on before.